Hello guys, welcome back to my channel. It's been a long time and I thought we should go back to our roots where we started from, vis-a-vis integration. So here's a nifty integral for you guys. Someone gave this to me as a challenge and I humbly accepted. So here's the integral. 13 sine of x divided by 5 sine of x plus 12 cosine of x dx. And also, do let me know about this new format of the iPad. This is an experiment, and I will continue or discontinue the use of such methods based on the feedback I receive for this and future videos. So I'm gonna take the 13 down, and I have something like this. Fair enough. Now, for the people who've maybe just started taking trigonometry or who have just a keen eye, you might notice that 5, 12, and 13, they form a Pythagorean triplet. And what's the physical significance of that? Well, I'll just draw it out. So if you take a right angle triangle, it's a horrible side. Yes, much better. And say I call this angle beta. Then if my hypotenuse is 13 and if my base is 5, then my height has to be 12. So what we can do is we can try to find the ratios of this triangle. So cosine of beta, for example, elementary trigonometry, is going to be 5 by 13. The sine of beta is going to be 12 by 13. And you notice we see these ratios appear in the denominator, which we can, and now we can plug these things in to simplify what our integral is. All of this might seem arbitrary, random, but you'll see the use of this. So I have a cosine beta sine x plus sine beta cosine x dx. Well, now you might remember the identity. Maybe I'll write it here. Sine of a plus b is sine of a cosine of b plus cosine of a sine of b. You see the denominator is in the red form of the identity, so we can just simplify it nicely by concluding it is sine of x plus beta. Well, how do we solve this integral? That significantly simplified stuff. Now you might see the idea of defining or using these trigonometric ratios. How's that going to help us? Well, now here's a really clever trick. So sine of x can be written as x plus beta minus beta. That's basically adding 0. And again, what's the purpose of that? Because I can expand this out using the counterpart for this sine of a minus b, which is sine a cos b minus cos a sine b. And a in our case is this red bracketed term x plus beta, and b is the beta. So just directly using that identity, we can significantly simplify and split the integral over this minus sign by linearity. We get sine of x plus beta cosine beta divided by sine of x plus beta dx minus, by splitting the integral up by linearity, I have a cosine of x plus beta, sine of beta, my bad, divided by sine of x plus beta with a dx. Well, notice this atrocious denominator goes away. Cosine beta, well, beta is a constant. Cosine beta is a constant. It's precisely 5 by 13. So I'm going to get cosine beta integration of antiderivative of, well, 1 is just x. So we get x minus sine beta can be pulled out being a constant. And we have a cotangent of x plus beta dx. Well, the cotangent of something linear, you can look at your formula sheet, or it's just a simple derivation. You use some u sub and you'll have a du over u form. You should conclude that this is natural log of sine of x plus beta. Don't forget the constant of integration, which is probably the most important thing in this video. So cosine beta is 5 by 13 and sine beta is 12 by 13. Natural log of sine of x plus, well, beta I can sub for beta. I can sub beta is cosine inverse. Yeah, I have space here. Cosine inverse of 5 by 13. That's beta. Cosine inverse of 5 by 13. Plus c, and that should be your answer. I'm pretty confident in my approach. Now just a small note here, it was really convenient to have a 13 in the numerator, but if we had arbitrary constants in the denominator and maybe some, I don't know, some unrelated constant d sine x or even cos, it doesn't matter, and then maybe e sine x plus f cosine x, what we would do is we would divide the denominator by the square root of e squared plus f squared, because if you make a triangle like this thing here, this square root guy here is going to be the hypotenuse of this new triangle, say gamma. E and f are going to be the other non-hypotenuse side. So you naturally synthesize a structure like that by dividing numerator and denominator by this factor. This factor is again a constant, so d over this constant will come out of the integration and everything else is going to follow as it is. So this procedure of dividing by this factor is what I call finding a common hypotenuse. And this ratio of e over square root of this quantity will always be less than 1, because this denominator is always greater than each e or f separately. So this really can be used to construct a triangle like this. This is a really nice trick, if you ask me, and this extremely useful for Olympiad problems and exam problems. It's not as robust or sophisticated as any of my other methods, but it works wonders. You can see how clean the answer is. It just simplified so much algebra for us. There's this one trick which is really clever. You might want to watch out for this. Everything else is pretty straightforward. So thanks for watching this video. Stay tuned. Peace out.